Hello, it's Duncan. Most people are setting up their JUnit tests wrong. In this episode, we'll look at how they're wrong, why so many tutorials are giving the wrong advice, and what we should be doing instead. To see the problem, let's look at JUnit 5's first test case. Here it is. Creates a calculator and asserts things on the calculator. And let's compare that with Google's fourth hit for JUnit. Here it is. You can see the difference. Here we declare a calculator, but we create it in our setup method, just before each. Here they are side by side. The JUnit documentation tells you to create a calculator in your constructor effectively, but Vogela tells us that we need to declare it and create the calculator in setup. It's not just the fourth hit that's wrong though. This is Google's third hit, and again we declare the output, and then in a before method, this is JUnit 4, we create the file. And here's the code in YouTube's top hit for JUnit, doing the same thing, declaring a contact manager and initializing it in a before each method. How did it get this way? Well, for old versions of JUnit, it had to be this way. This is the JUnit 3 cookbook, and in JUnit 3, test cases were all created before any of them were run. And so if we'd created fixture properties as part of the construction of a test case, they would all happen up front. That's not disastrous in many cases, but the pattern was to create them in a setup method so that we knew they were going to happen just before this particular test was run. JUnit 4, though, introduced a new test lifecycle. It created each instance of test just before the test was due to be run. That means there's very little difference in lifecycle terms between creating fixture properties as part of the constructor or as part of the setup. Creating them in the setup, though, is a lot more wordy, as you can see here, and it prevents us making the fields of our test final, because we need to assign to them in setup. Now this is the JUnit 4 documentation, and unfortunately this example wasn't updated to take advantage of the new lifecycle, and so most people took this as the way things should be done. How do I know I'm right? Well, this is an email I wrote in 2006 to the JUnit Yahoo group, asking whether this is the actual behaviour of the framework. And here's a reply from David Saff, who was writing JUnit 4 with Kent Beck at the time. And here's Kent's take. Is it still safe for JUnit 5? Well, yes, because JUnit 5 shows the constructor style in its very first example test. And here's the JUnit documentation on the test lifecycle. Note there is a way of configuring JUnit with lifecycle per class. That means we might have to use it before all to set up our test properties, but that's not the default. Let's have a look at the test lifecycle as it applies to the last tests we wrote in Gilded Rose, our fake value alpha tests. Here, all of our test fixture properties are initialized as part of the constructor. And we know that a new instance of this test class is created before each one of these tests is run. And that's why it doesn't matter that this test mutates our price lookup. This test here will have a fresh price lookup to run with. We can see the relationship between constructing these properties and the setup method if we put one in. So we'll say at before each setup, or we'll just print something out in here. And we'll also print once we've created, for example, the client here. And in each one of these tests. And now let's run. What happened? Well, the client was created, and then setup was called, and then test 3 was run. And then the client was created, setup was called, test 2 was run. Why were these run in this order? Well, because JUnit runs tests in something of a random order, in order that we don't have dependencies that mean that we have to run test 1, followed by test 2, followed by test 3. One good reason for making sure that we don't have those dependencies is that if we don't, then we can run our tests in parallel. And in fact, JUnit allows us to do that. We can specify execution and give it execution mode concurrent. And if we do and run that, then you'll see that what happens here is that we create 4 clients, run 4 setups, and run 2, 1, and 3. Why 4? Well, because in fact we have a disabled test down here, and JUnit actually creates a test to run that even though it isn't going to. Go figure. If we remove the execution mode and give ourselves a finalizer, and then garbage collect in each one of our tests before we run it, then we can see that the finalizers here are actually run, which shows us that JUnit not only creates the test just before it's run, but also releases it after it's been run. So that means that any properties that we create in here will be let go of. We can allocate large amounts of memory, for example, and that won't affect later tests. That might be significant because one of the things I like to do is to move these sort of things, just test data, stateless things, out of the test altogether and put them at the top level. Maybe mark them as private. That leaves us with only the stateful things, which is to say the client, which depends on the roots, which depends on a mutable map. That leaves only those things as the properties of the test. It does mean that these items, which are effectively static then, can't be garbage collected. In case of small items, it doesn't really matter, and I think communicating about state in the test is quite important. On which subject I think I might name these, for example, just a URI, and this to be just an item. Showing they're not really crucial to the test, they're just used by it. Just clear out our extra gubbins. Now let's have a look at another way we could structure this test. What we could do is we could create two types of items, an item and a not found item. And we call this one no such. If we did that, then we could populate our map early on. So now we could take the key here to the value here, and we could explicitly say that for a not found item, that that's null. Now if we do that, we don't have to populate our price lookup. And here we'd say this is a not found item. Just try running that. Now then, our price lookup doesn't need to be mutable. So we can just say this is a map. And as soon as nothing in our test has any state, we can actually move it all out now into here. Now, should we do this? Probably not, because people expect tests to create their collaborators as part of the fixture. So we should probably take these and move them back into here. But we should certainly, when we create tests, be thinking about what is stateful and what isn't. Comparing the two types of testing, on the left-hand side here, we introduce what's going to happen by mutating the price lookup, by setting it up in a particular test. On the right-hand side, we set up the same conditions for every test, but we use a different item, an item and not found item, to communicate the difference between returns price that does exist and returns null for no price. Which is better? I think it's very much a question of taste. The right-hand side version works well when we only have a couple of variations and we can express them in the names of different items. And the left-hand one works well when we have lots of different combinations and it would be confusing to try and set up all the test data to start with. At the moment I think this is quite a nice formulation, so we'll leave this one here. Before we go though, let's just have a look at what would happen if we did try and use a before each in Kotlin to set up, for example, our client. We would have a at before each, fun setup, and we would initialize our client in here. But in Kotlin we can't change the value, like a final in Java, so we'd have to make this into a var. Now in order to initialize it somewhere else we have to tell it its type. So that's our type, and now we could remove this. But wait, we can't because we have to give it some value because Kotlin doesn't know we're always going to call this before each. So we might try and initialize it to null, but now this isn't a nullable type. So we'd end up saying that that's a nullable one of these. But now everywhere we use it, Kotlin knows that it could be null. There is a solution to this problem if we go back, which is what IntelliJ is suggesting here, which is that we make it late in it. That allows us to say we're definitely going to set it up somewhere, in this case here. So this will work in the same way as a constructor, but I hope you'll agree it's a lot uglier compared to just having a val that we set up as part of construction. In Java there was one more place that we might actually use a setup, and that we do populate things or start them maybe. So we might have, and if this was a mutable map again, but started off empty, then we might take our price lookup and populate it in a before each. Run that. The fact is though, in Java we could always use a non-static initializer to do that, and in Kotlin we could always use init. So this will have the same effect. Not only that, we have scope functions like apply that allow us to do these things in line here, so that we take this code and initialize in an apply. Run is another scope function which is particularly useful in this case. But we don't want to do that anyway. We want to go back to where we were with a nice immutable map. And a nice simple test. Well, that's the end of me moaning about how people use JUnit. If you subscribe to the channel using the button below, I promise not to moan so much next time. And if you've enjoyed this, then I think you'll enjoy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.